Welcome to today class of nonlinear vibration. So, today we are going to study KBM method, that is Krylov-Bogoliubov and Mitropolski method of averaging. So, this is one of the solution method for this nonlinear equation of motion. So, previously we have studied van der Waals equation, Krylov-Bogoliubov technique and generalized method of averaging. So, these are different methods of averaging, and today class this Krylov-Bogoliubov and Mitropolski technique will be dealt with. So, this is an extension of this Krylov-Bogoliubov technique, which was developed in 1947 by this Krylov-Bogoliubov, and later it was modified by this Bogoliubov and Mitropolski in 1961, and Mitropolski further used it is for non-stationary system in 1965. So, in this method, so this is the extension of this Krylov-Bogoliubov method, and already we know in case of the Krylov-Bogoliubov method. So, in case of the Krylov-Bogoliubov method, the differential equation, if we are considering the differential equation in this form, that is d square u by dt square plus omega 0 square u equal to epsilon f, which is a function of u and u dot. So, then we are assuming the solution to be a t cos omega 0 t plus beta 0 t. So, this is in this case initially by assuming this part equal to 0, the solution can be written as a cos omega 0 t plus beta, where a and beta are constant, but when we are taking this right hand side term, that is epsilon f, which is a function of u and u dot, then instead of assuming this a and beta to be constant, so we are assuming this a and beta are function of time, and for small nonlinear terms. So, we are assuming these a and beta are slowly varying function of time. So, in this case, by taking this phi equal to omega 0 t plus beta 0 t. So, this equation is written in this form u equal to a t cos phi. So, in this case they assumed, that is Krylov and Bogoliubov assumed that this u dot can be written in this form, that is u dot equal to minus omega 0 a t sin phi, and this du by dt equal to minus a omega 0 sin phi plus dA by dt cos phi minus a d beta by dt sin phi. So, following in this way, so one can write this d square u by dt square equal to minus a omega 0 square cos phi minus omega 0 dA by dt sin phi and minus a omega 0 d beta by dt cos phi. So, substituting these equations, that is d square u by dt square and this u dot equal to minus omega 0 a t sin phi, and also this du by dt equal to minus a omega 0 sin phi plus dA by dt cos phi minus a d beta by dt sin phi in the governing equation, then one can write this equation in. So, one can write the equation or one obtain this equation. So, where one can write this minus a omega 0 square cos phi minus omega 0 dA by dt sin phi minus a omega 0 d beta by dt cos phi plus omega 0 square u a cos phi equal to minus epsilon f a cos phi and minus omega 0 a sin phi. So, for u, so one substitute this a cos phi. So, now separating, so now from this equation one can write this minus omega 0 dA by dt sin phi. So, one can equate the order of epsilon and write the equation, and from those equations one can find this dA by dt equal to minus epsilon by omega 0 sin phi f a cos phi minus omega 0 a sin phi. Similarly, d beta by dt equal to minus epsilon by a omega 0 cos phi f a cos phi minus omega 0 a sin phi. Here it is assumed that as a and beta are slowly varying function of time. So, this dA by dt will be of the order of epsilon, and so the variation will be very small, so that one can average this with a period 0 to t, and one can write this dA by dt in this form. So, in this Krylov-Bogoliubov method, so one can take this integration, that is dA by dt equal to minus epsilon by 2 omega 0 2 by t 0 to t sin phi f a cos phi. So, this is for u and this part is for u dot. So, this one can integrate it from, or one can average it out in a cycle from 0 to t, and one can write the expression for dA by dt and d beta by dt. So, for different function f, by substituting this for u equal to a cos phi and u dot equal to minus a omega 0 sin phi, one can find this dA by dt and d beta by dt, and from this by integrating one can find a and beta. So, after finding a and beta, one can find the solution of the system. So, this is the method of Krylov and Bogoliubov, but in case of Krylov, Bogoliubov and Mitropolski, so there is a modification of this equation. So, instead of using that integration, so here it is the solution can be assumed in this form. So, the solution can be assumed as a cos theta, where theta equal to your omega 0 t. So, one can assume this u equal to a cos theta plus summation n equal to 1 to n epsilon n u n, where u n is a function of a and theta, and one can neglect the order of epsilon to the power n plus 1. So, considering up to nth mode, so one can neglect after n plus 1. So, one can write, so this is capital N plus 1. So, this in this case this a and theta are function of time. So, this dA by dt can be written. So, this dA by dt. So, here u n is a function of a and theta, and this a. So, Krylov-Bogoliubov according to this technique. So, one can take this dA by dt in this form. So, here u n is a periodic function of period 2 pi. So, now by taking this dA by dt in this form, that is n equal to 1 to n epsilon n. So, epsilon is the bookkeeping parameter. So, epsilon to the power n a n, which is a function of a only. Similarly, d theta by dt equal to omega 0 plus n equal to 1 to n epsilon n theta n. So, this epsilon is the bookkeeping parameter. So, here it is assumed that this a n, capital A n and theta n are function of a only. So, for example, if one take n equal to 2, so this thing can be written as, so dA by dt can be written as epsilon a 1 plus epsilon square a 2. Similarly, this theta d theta by dt can be written as omega 0 plus epsilon 1 theta 1 plus epsilon square. So, epsilon, so this is epsilon theta 1 plus epsilon square theta 2. So, here we are neglecting the higher order, that is order of epsilon q is neglected here. So, by neglecting the order of epsilon q, one can write this dA by dt equal to epsilon a 1 plus epsilon square a 2. Similarly, this d theta by dt is written as omega 0 plus epsilon theta 1 plus epsilon square theta 2. So, instead of integrating as in case of this Krylov-Bogoliubov method, so here it is written in this expansion form. This dA by dt and d theta by dt are written in this expansion form, and now one can write this d square by dt square equal to, so this d square by dt square can be written d by dt of d by dt, and by expanding that thing one can write this will be equal to dA by dt square into del square by dt square plus d square a by dt square into del by del a plus 2 into dA by dt. So, 2 into dA by dt into d theta by dt into del square by, so it will be del square by del a del theta plus d theta by del t whole square into del square by del theta square plus d square theta by dt square into del by del theta. So, now d square a by dt square can be written as d by dt of dA by dt. So, again we know this dA by dt we are writing in the form of epsilon a 1 plus epsilon square a 2 plus epsilon cube A3 if you are taking 3 terms, or if you are taking n term, it can be written in the summation form. So, one can write, so this d square A by dt square equal to dA by dt into d by dt of dA by dt. So, it will be equal to d by dt dA by dt into, so this n equal to 1 to n epsilon n dAn by dA. So, as we are substituting this dA by dt in terms of An, that is A1, A2, A3, A4 or An. So, this d square A by dt square can be written dA by dt n equal to 1 to n epsilon n dAn by dA. So, one can put for n equal to 1. So, this will become, so one can write this dAn by dA. So, dA by dt. So, already dA by dt is written in this form, that is epsilon A1 epsilon square A2. So, in this form. So, now differentiating that thing. So, one can write, so this will be epsilon square A1 into dA1 by dA plus order of epsilon cube. So, one can write, expand this part, that is dA by dt. So, this thing can be written dA by dt. So, for this part it will be equal to epsilon dA1. So, one can write, expanding this thing. So, it can be written epsilon 1 dA1 by dA plus epsilon square dA2 by dA. So, in this form. So, by substituting this thing in this equation, it can be written, it is equal to epsilon square A1 dA1 by dA. Similarly, d square theta by dt square can be written as d by dt of d theta by dt. So, this is equal to dA by dt into d by dA of d theta by dt. So, this will be equal to, so already we know this d theta by dt in this form. So, it can be written as d by dt of this. So, it will be, by expanding this thing one can write. So, this is equal to epsilon square A1 d theta 1 by dA. So, now substituting these equations in the governing equation and separating the order of epsilon, one can get a set of equations, and from those set of equation, if one kill the secular terms, so one can find the required equations for the governing solution of the governing equation. So, we can see one example, that is the Duffing equation. Let us take the cubic order polynomial. So, in this case one can write this u double dot, this equation can be written in this form, that is u double dot plus omega 0 square u plus epsilon u cube equal to 0. So, in this case we can assume, let us assume up to second order. So, we can write this u equal to a cos theta plus epsilon u1 a theta plus epsilon square u2 a theta. Now, for this u double dot, by substituting this u double dot means d square u by dt square. So, one can write this thing d square u by dt square. So, this thing can be written as dA by dt whole square plus del square u by dt square plus d square a by dt square del u by del a plus 2 dA by dt del theta by dt del square u by del a del theta plus del theta by d theta by dt whole square into del square u by del theta square plus d square theta by dt square into del u by del theta. But in this case now again substituting this d square a by dt square equal to epsilon square a1 dA by dA1 by dA and d square theta by dt square equal to epsilon square a1 d theta 1 by dA, and substituting this u equal to a cos theta plus epsilon u1 plus epsilon square u2. So, and separating the order of epsilon, one can obtain a set of equations. So, now one can see, so for d square u I have shown you that equation what you have to use. For omega 0 square u, simply multiplying this omega 0 square term, one can get this omega 0 square a cos theta plus omega 0 square u1 a theta plus omega 0 square epsilon square u2. Now, for this term epsilon u cube, So, now one can cube this term. So, it will be a plus b. So, it can follow the form a plus b plus c whole cube. So, one can find the cube of this term, and by expanding this and then separating the order of epsilon. So, one can get the first equation, one can get this is the first equation. So, it will be omega 0 square del square u 1 by del theta square plus omega 0 square u 1. So, this will be equal to 2 omega 0 theta 1 a cos theta plus 2 omega 0 a 1 sin theta minus a cube cos cube theta. So, now writing this cos cube theta equal to cos 3 omega t. So, for this omega t one can put theta. So, cos cube theta can be written as cos 3 theta plus 3 cos theta. So, substituting this cos cube theta equal to 3 cos theta plus cos 3 theta plus 3 cos theta by 4. So, one can write this equation, that is omega 0 square del square u 1 by del theta square plus omega 0 square u 1 equal to 2 into omega 0 into theta 1 a cos theta plus 2 omega 0 a 1 sin theta minus a cube into a cube by 4 into cos 3 theta plus 3 cos theta. So, now due to the presence of this term, that is sin theta and this cos theta. So, the solution will lead to infinity, because the left hand side we have this term, this omega 0 square del square u 1 by del theta square plus omega 0 square u 1. So, if we will take this cos term, then in this case, so we will have, for example, so in this case as the left hand side we have omega 0 square. So, in the left hand side we have omega 0 square del square u 1 by, so we can see this term. So, this is omega 0 square del square u 1 by del theta square plus, so this omega 0 square we can take common. So, in this case it will becomes omega 0 square into del square u 1 by del theta square plus u 1. So, the auxiliary equation becomes d square plus u 1. So, d square plus u 1 will be equal to, so d square plus, so the auxiliary equation I can write in this. So, this is omega 0 square into d square plus omega 0 square. So, u 1. So, this will be equal to 2 omega 0 theta 1 a cos theta. If you take only this term, so this due to the presence of this theta, so theta equal to our omega t plus omega 0 t. So, as it contain this theta contain omega 0 t. So, this will be a secular term, as we can by substituting this omega 0 here. So, d square will be equal to minus omega square. So, this term will leads to, so this term will lead to infinity. So, this will be a secular term. Similarly, this will be a secular term, and for cos q theta we have substituted this term, that is 3 cos theta. So, that will also be a secular term. So, to eliminate the secular term, so we have to equate the coefficient of sin theta equal to 0 and coefficient of cos theta equal to 0. So, by equating the coefficient of sin theta equal to 0, so that means 2 omega 0 a 1 equal to 0. So, we have this a 1 equal to 0. So, we got this condition that a 1 equal to 0. Otherwise, if we are not putting a 1 equal to 0, so one can find the solution to be infinite, which is not possible in practical system. So, this term has to be eliminated, that means a 1 equal to 0. Similarly, taking this term and the part of this a cube 3 by 4 cos theta. So, one can write the second equation. So, after substituting this cos cube theta, one can retain this equation in this form. So, now equating the coefficient of cos theta. So, this is cos theta and this term is also cos theta. So, one can write this 2 omega 0 theta 1 a to omega 0 theta 1 a minus this a cube by 4 3 a cube by. So, this is 3 a cube by 4. So, this is cos theta. So, now to eliminate the secular term. So, we have to substitute this part equal to 0. So, by writing this is equal to 0. So, we can write by taking this a common. So, one can write a into 2 omega 0 theta 1 minus 3 a square by 4 equal to 0, or either a equal to 0 or so a equal to 0 corresponding to the trivial solution. So, otherwise one can write this theta 1 equal to 3 a square by 4 into 2, that is 8 omega 0. So, we got this condition, that is theta 1 equal to 3 a square by 8 omega 0 and a 1 equal to 0. So, by eliminating the secular term, so we got this expression. So, in this case, instead of taking two terms, if one take one term only, that is u equal to a cos theta plus epsilon u 1 a theta, then one can go up to this term and one can find the solution. So, the solution could have been u equal to a cos theta plus epsilon u 1. So, in this case, after eliminating the secular term, the remaining terms will be, so this term is a secular term, this is also a secular term and this is also a secular term. Now, the remaining term is this, that is cos 3 theta minus a cube by 4 cos 3 theta. So, the solution will be, the equation, remaining equation becomes del square u 1 by del theta square plus omega 0 square u 1 equal to minus a cube by 4 cos 3 theta. So, the solution of u 1 will be equal to a cube. So, this is a cube by, so this is 4. So, and we have to divide this omega 0 square here. So, this becomes, so in this case this becomes a cube by 4 cos 3 theta by, so if I will write the auxiliary equation, so it will be by d 0 square plus omega 0 square. Now, in place of d 0 square I have to substitute this 3 square, that is 3 square equal to 9. So, minus 9 omega 0 square. So, minus 9 omega 0 square plus omega 0 square, this becomes minus 8 omega 0 square. So, 8 into 4, 8 into minus 4 and this has a minus sign. So, this becomes u 1 equal to, u 1 become a cube by 32 omega 0 square cos 3 theta. So, we obtain this u 1 equal to a cube by 32 omega 0 square cos 3 theta and this a 1 equal to 0. Now, by substituting this u 1 in the second equation, so in this case this is the first equation, the second equation we obtain to be this, that is your omega 0 square del square u 2 by del theta square plus omega 0 square u 2. So, this is will be equal to 2 omega 0 theta 2 plus theta 1 square a minus a 1 into d a 1 by d a into cos theta plus 2 omega 0 a 2 plus a 1 theta 1 plus a 1 del theta 1 by del a sin theta minus 3 u 1 a square cos square theta minus 2 omega 0 theta 1 d square u 1 by d theta square minus 2 omega 0 a 1 d square u 1 by d a d theta. So, in this case we can substitute this cos square theta. So, in terms of cos theta we can write. So, 1 plus cos 2 theta. So, this cos square theta can be written as 1 plus cos 2 theta by 2. So, we can substitute that thing in this equation and now similar to the previous case we can see that the coefficient of this cos theta or the terms containing this cos theta and sin theta should be eliminated to eliminate the secular terms. Otherwise, these terms will lead to the infinite response, which is not practically possible. So, one has to eliminate the secular term. So, to eliminate the secular term, so we can have we have to substitute this part equal to 0. Similarly, we have to substitute this part equal to 0. So, by substituting this is equal to 0. So, what you can get? So, we can obtain. So, in this case we can obtain this. So, this is the equation after simplification. So, after simplification the equation reduces to this omega 0 square del square u 2 by del theta square plus omega 0 square u 2 equal to 2 omega 0 theta 2 plus 15 a fourth by 128 a 0 omega 0 square into a cos theta plus 2 omega 0 a 2 sin theta plus a to the power 5 128 omega 0 square into 21 cos 3 theta minus 3 cos 5 theta. So, we obtain this thing by substituting the value of u1 what we obtained before. So, this u1 equal to a cube by 32 omega 0 square cos theta. So, we have substituted in this equation in this part, and now clubbing the coefficient of cos theta and sin theta. So, we have written this equation in this form. So, the resulting equation becomes this omega 0 square del square u 2 by del theta square plus omega 0 square u 2 equal to 2 omega 0 theta 2 plus 15 a fourth by 128 omega 0 square a cos theta plus 2 omega 0 a 2 sin theta plus a to the power 5 by 128 omega 0 square into 21 cos 3 theta minus 3 cos 5 theta. So, similar to the previous case, here also we have to eliminate the coefficient of cos theta and sin theta separately. So, eliminating the coefficient of sin theta, so we can write this a 2 equal to 0, because the coefficient of sin theta equal to 2 omega 0 a 2. So, this a 2 should be equal to 0. So, a 2, so we have put this a 2 equal to 0. Now, similarly killing this coefficient of this cos theta term, that is 2 omega 0 theta 2 plus 15 a fourth by 128 omega 0 square. So, we can put this term equal to 0. So, by substituting that thing we can write this theta 2. So, this theta 2 now it becomes minus 15 a fourth by 256. So, these 2 can be multiplied here. So, this theta 2 becomes 15 minus 15 a fourth by 256, omega 0 square is here and omega 0 multiplied again. So, this becomes minus 256 omega cube. So, we can write. So, now these two terms have been eliminated. So, as this term and these terms we have already eliminated, the resulting equation becomes omega 0 square del square u by del square u 2 by del theta square plus omega 0 square u 2 equal to a to the power 5 128 omega 0 square into 21 cos 3 theta minus 3 cos 5 theta. So, now the solution of this u 2. So, we can show the auxiliary equation. So, we have this by dividing this omega 0 square. So, we have this equation del square u 2 by del theta square plus, now we have only this u 2 so this will becomes, so we can write this term. So, that means we can write this is equal to a to the power 5 by 128 omega 0 square into 21 cos 3 theta minus 3 cos 5 theta. So, in this case cos 3 theta cos 3. So, this is omega 0 square we will have. So, in this case, so by substituting for this term, that is your our auxiliary equation will be d square plus omega 0 square. So, as the auxiliary equation will be this into u 2 will be in the right hand side. So, in place of this d square we have to substitute this square of this 3 or square of this 5. So, we have to substitute minus 9 omega 0 square, or we have to substitute, in this case we have to substitute omega. So, we have to substitute, in second case we have to substitute minus 25. In the first case we have to substitute minus 9. So, minus 9 plus 1, that is 8. So, if you multiply that thing, so it becomes 1024 omega 0 fourth, and similarly this 3 by, so here 24, 3 by 24. So, this 3 by 24. So, this becomes 1 by 8. So, this 1 by 8 when it is multiplied with this 256, this becomes also 1024. So, one can obtain this u 2. So, this u 2 becomes minus a to the power 5 1024 omega 0 to the power 4 into 21 cos 3 theta minus cos 5 theta. So, we now obtain u 2, also previously we obtained u 1 and this theta 1 and theta 2. Similarly, we obtain this a 1 and a 2. So, after obtaining all these things, so one can now revert back to the original equation, that is this u equal to a cos theta plus epsilon u 1 plus epsilon square u 2. So, we already know u 1 expression for u 1 and expression for u 2. So, by substituting these expressions, so we can write. So, now let us substitute these expression and see. So, we can write this u equal to a cos theta plus epsilon. So, for u 1 we are substituting a q by 32 omega 0 square cos 3 theta, and for this u 2 we have substituted this equation. So, it becomes epsilon square a to the power 5 by 1024 omega 0 fourth into 21 cos 3 theta minus cos 5 theta. So, this is loss. So, we have neglected the order of epsilon cube. So, in this case till now we do not know what is a and theta. So, now we can substitute. So, or we know this dA by dt equal to epsilon a 2 plus epsilon a 1 plus epsilon square a 2, and already we obtained this a 1 equal to 0 and a 2 equal to 0 previously. By eliminating the secular terms, we already got a 1 equal to 0, and here in the second case we got this a 2 equal to 0. So, by substituting these two, so we can get, so this part equal to 0 and this a 2 also equal to 0. So, this dA by dt equal to 0. As dA by dt equal to 0, so by integrating, so one can get, so a will be a constant. So, one can write this a equal to a 0. So, this is a constant. So, in this equation u equal to a cos theta, so here we obtain this a to be a constant. Similarly, now for theta, so this d theta by dt we can write. So, following this equation, so we can write this d theta by, so we know this d theta by dt expression. So, we can write d theta by dt equal to omega 0 plus epsilon theta 1 plus epsilon square theta 2 plus higher order terms. So, already we obtained this theta 1 and theta 2. So, we can write, so this, in this case we can write this d theta by dt equal to omega 0 plus epsilon 1 theta 1. So, for theta 1 we have written this is equal to 3 a square by 8 omega 0. So, for theta 2 we have written this epsilon square into 15 a to the power 4 by 256 omega 0 cube. So, already we know a is constant. So, we can write this theta will be equal to, by integrating this thing. So, we can write, so this will be multiplied by t plus theta 0. So, theta, so this expression for theta becomes omega 0 t plus epsilon into 3 a square by 8 omega 0 minus epsilon square into 15 a fourth by 256 omega 0 cube into t. So, plus this theta 0. So, from initial condition one can get this a 0 and theta 0, and one can write the final expression of the system in this form, that is u equal to a cos theta plus epsilon a cube by 32 omega 0 square cos 3 theta minus epsilon square a to the power 5 by 1024 omega 0 fourth into 21 cos 3 theta minus cos 5 theta, where theta equal to this. So, in this way, by using this KBM method, that is Krylov-Bogoliubov and Mitropolski method, so one can find the solution of a nonlinear equation. So, one can go up to any accuracy by increasing this order of epsilon. So, instead of taking a single term or two term, one can take higher order terms to find the solution of the governing equation, but adding higher order terms will make the calculation or make the computation very cumbersome. One can, so in that case one can use the computer to find the solution in case of the higher order terms. So, for manual calculation one may go up to the second order term and one can find the solution. So, this method has been followed from the book by Nafe, perturbation method. So, from the book of perturbation method. So, it is followed from the example by the book perturbation method by A.H. Nafe. So, we can take another example. So, that is Van der Pol equation also. So, let us take the second example, that is Van der Pol equation, and in this case also we can write the equation in this form. The Van der Pol equation can be written in this form, that is okay. So, let us take the second example of Van der Pol's equation, example 2. So, in this case the equation can be written in this form, u double dot plus u. So, minus epsilon into 1 minus u square into u dot equal to 0. So, this is the equation, or this equation one can write in this form also, u double dot plus u equal to epsilon into 1 minus u square into u dot. So, now by substituting u equal to a cos theta plus epsilon u1 plus epsilon square u2, where this u n are function of periodic function of theta. So, with a u1 u2 are periodic function of theta with a period of 2 pi. So, following the previous case, so we can write this equation by substituting this equation in the first equation. We can write this del square u by, so we can write this equation in this form. So, del square u1 by del theta square plus u1 will be equal to 2 theta 1 a cos theta plus 2 a1 sin theta minus a into 1 minus 1 by 4 a square sin theta minus 1 by 4 a cube sin 3 theta. Similarly, the second equation can be written in this form, that is del square u2 by del theta square plus u2. So, this will be equal to 2 theta 2 plus theta 1 square into a minus a1 into del a1 by del a small a. So, this is this multiplied by cos theta, similarly plus 2 into a2 plus a1 theta 1 plus a1 del theta 1 by del a. So, this into sin theta. So, this equation again can be written in this form, that is minus 2 theta 1 del square u1 by del. So, the first equation. So, here we can write it again to in this form, that is 2 theta 1 del square u1 by del theta square minus 2 a1 del square u1 by del a del theta plus 1 minus a square cos square theta into a1 cos theta minus A theta 1 sin theta plus del u 1 by del theta. So, plus u 1 A square sin 2 theta. So, from this we can obtain by eliminating the secular term. So, we can write this A 1 equal to half A 1 minus 1 by 4 A square and this theta 1 equal to 0. Now, we can write this u 1 equal to A cube by 32 by eliminating the secular term. We can write this u 1 equal to A cube by 32 sin 3 theta and substituting this equation in the second equation. So, we can write this del square u 2 by del theta square plus u 2. So, this is equal to 2 A theta 2 minus A 1 into d A 1 by. So, this is d A 1 by d A plus 1 minus 3 by 4 A square into A 1 plus A cube by 128. So, into cos theta plus 2 A 2 sin theta plus A cube into A square plus 8 by 128 cos 3 theta plus 5 A to the power 5 by 128 cos 5 theta. So, following the previous method, here also we can eliminate the secular term. So, the secular term can be eliminated by eliminating the coefficient of cos theta and sin theta. So, here coefficient of sin theta equal to A 2. So, we have to eliminate this term A 2. So, we have to put this A 2 equal to 0. Similarly, by eliminating the coefficient of cos theta, so we have to eliminate this part. So, from this already we know the expression for A 1. So, by writing the expression for A 1 in this case and eliminating the secular term. So, we can write this A 2 equal to 0. So, eliminating secular term. So, we can write this A 2 equal to 0 and also we can write this theta 2. So, from this we can write. So, from this expression we can find theta 2, that is 2 A theta 2 minus A 1 into d A 1 by d A plus 3 plus 1 minus 3 by 4 A square A 1 plus A cube by 128, this thing should be equal to 0. So, by equating this part equal to 0, that means coefficient of cos theta. So, by equating this equal to 0, so we can write theta 2 equal to, so this will give theta 2 expression. So, theta 2 equal to A 1 by 2 A into d A 1. So, this becomes by d A 1 by d A minus 1 plus 3 by 4 A square minus A to the power 4 by 256. So, now as we have obtained this or eliminated this term and these two terms we have eliminated. So, the remaining terms, we have two remaining terms, that is this term and this term. So, from this, so we can write the expression for u 2. So, we can write this u 2 will be equal to. So, in this case the auxiliary equation becomes d square plus 1. So, by substituting for d square for this term minus 9. So, this becomes by 8. So, 128 into 8. Similarly, in this case this is minus 25 plus 1, this becomes minus 24. So, minus 24. So, 5 by 128 and in the bottom or denominator part we have this minus 24. So, we can write this expression for u 2 in this form. So, u 2 will be equal to minus 5 A to the power 5 by 3072 cos 5 theta minus A cube into A square plus 8 by 1024 cos 3 theta. So, now already we have this expression for A 1, A 2, theta 1, theta 2 and u 1, u 2. So, we can write this u. So, this is equal to A cos theta u equal to a cos theta plus epsilon u1 plus epsilon square u2. So, for this we can write this is equal to minus a cos theta minus epsilon a cube by 32 sin 3 theta minus epsilon square a to the power 5 by 1024 into 5 by 3 a square cos 5 theta plus a square plus 8 into cos 3 theta. So, this into this plus order of epsilon cube. So, in this case till now we do not know what is a and theta, and we can write this a and theta in this form because we know dA by. So, we know this expression. So, dA by dt we know. So, dA by dt equal to epsilon. So, from the previous expression for dA by dt. So, this is the equation for dA by dt. Already you know the expression for dA by dt what we have assumed. So, dA by dt equal to epsilon a1 plus epsilon square a2, and already we know the expression for a1 a2. Similarly, d theta by dt equal to omega 0 plus epsilon theta 1 plus epsilon square theta 2. So, from this expression, so we can write this dA by dt will be equal to. So, this dA by dt equal to, we can write this is equal to epsilon a by 2 into 1 minus 1 by 4 a square, and this a square can be. So, from this dA by dt equal to epsilon a by 2 1 minus 1 by 4 a square. So, now we can integrating these things. So, we can write a square equal to, by taking this a square. So, we can find this a square equal to 4 by 1 plus 4 by a square minus 1 e to the power minus epsilon t. So, this is the expression for a square we obtain. Similarly, writing by d theta by dt. So, we can write this is equal to 1 plus epsilon square into a 1 by 2 a into d a 1 by dA minus 1 plus 3 by 4 a square minus a to the power 4 by 2 56. So, from this we can write this d theta by dt. So, this will be equal to 1 minus epsilon square by 16 minus epsilon by 8 a into 1 minus 7 by 4 a square into dA by dt. Already we know dA by dt. So, we can find this theta equal to t minus epsilon square by 16 t minus epsilon by 8 ln a plus 7 epsilon by 64 a square plus epsilon 0 or plus theta 0. So, this is the expression for theta, and already we got the expression for a square this, and we obtain the expression for u this way. So, this gives the solution for the van der Pol equation. So, in this way, by using this KBM method, that is Krylov-Bogoliubov-Mitropolski method, so one can find the solution of a nonlinear equation up to any higher order precision. So, next class we will study some other methods or recently used methods like this incremental harmonic balance method and intrinsic harmonic balance method, and some other newly developed method used in this nonlinear solution of nonlinear equation motion. Thank you.